Hi guys, here a quick review of my Apollo heat pump. I purchased it about 2 years ago. I made my research and MB Tech was by far the best offering on the market. The price was better, product specs was looking better, and now with experience I can say that is by far the best unit on the market. I live far north, the same elevation as Alaska, so we get commonly minus 30 Fahrenheit. And guess what? I'm relying on my Apollo. Cut my bill by twice compared to gas, and no pollution. It's all green, so it's efficient, it's cost effective, and it's green, and it's very silent. Like now it's probably running at solid 60-70% capacity, and it's just a wind, a breeze sound, and yeah, made install myself. It's so easy because it is a air-to-water heat pump. Actually, you should never put water. It's glycol, right? It's 40% glycol. They suggest, the team. They have great tech support. If you have any questions, you just call them. The unit is fully certified, CSA, UL, Energy Star, and all that you can wish for. They have many kind of unit for 410A, R32. When I'm in my install, I use pool insulation. Found Walmart. I use some webbing for the covering. Very simple, just roll it up. PEX, 1-inch PEX. That's a 5-ton unit covering my 1,500 square feet house. I did go for like a gigantic concrete base. That was my idea. Kind of like it because it's strong and it doesn't get pushed too much by ice, because with all of the defrost cycle you're gonna get a lot of water accumulation because it's defrosting, so the water trickles down and this transforms into ice. So you rather have a solid base, at least something that is bolted to something. If not, it's probably gonna get pushed by the ice or something. Yeah, what to say? Well, it does my domestic water as well, and my cooling, of course. That's the whole point of having a air-to-water heat pump. It does pretty much whatever you want it to do. Time to install spa also with it. Apollo is the only supplier in the market that offer complete heat pump solution that provides pool, spa, heat, and cooling. So if you're looking for that kind of application, well, I guess MB Tech is pretty much the way to go. Well, that's about it. Let me look at it, show you from the inside. Hi, I'm inside the home. Here my Apollo thermostat. It's a 3-speed fan coil. I'm using it with my 3-speed Coleman. It's just a standard furnace. The only difference is that I insert some air to water coil. As you know, these is actually glycol, and this is just 3/4 packs connected to 3-layer of air to water coil. So that's like 1 layer here, 2nd layer, 3rd layer. Why so? Because with air to water heat pump, it's important to have lower heating temperature to have greater efficiency. So, you know, it's really great for radiant floor or, you know, high surface area fan coil. Yeah, even the dogs are happy about it. Yeah, that's my review of the Apollo heat pump. Thank you.
Good day, everybody. My name is Wade, and this morning or this afternoon, not sure what time it is, I will be reviewing my brand new Apollo 5-ton air-to-water heat pump. Recently got this installed. It's replacing an old Aqua Products unit that I purchased and installed 15 years ago. I hunted around for quite a long time, and some of the units were ridiculously expensive. The installation costs were ridiculously expensive. So I decided to just purchase this and do it myself, and it came out real nice. So I'm going to go over that real quick with everybody. So this is the unit. It's real nice, has a real nice look to it. If you look at my pad, the concrete pad that it sits on, that is the footprint of the original reverse cycle chiller that I had on there. So you can see that the new unit is much smaller. And I can tell you that it weighed a lot less when I put it in. So to do the installation, you don't need a license, you don't need training, but you do need to know your way around electrical and plumbing and just basic use of tools. But there's nothing here that's beyond your regular motorhead's skill set. So let's get into it. There's 3 steps to install this thing. First thing is we put it in place, we bolt it to the ground. Step 1. There are 4 feet, easy enough. Concrete bit. Drill the holes, fasten it down, you're all set. Second part of the install is the plumbing. In my cellar, I have a 75-gallon tank filled with a mixture of water and glycol, probably about 50-50. From that tank, there's an 1.25 inch pipe that runs along here, one of these silver pipes, to the inlet, and then the outlet goes back to the tank. Down in the basement as well, there's a circulator pump that pumps the water from the tank through this heat pump and then back in. This unit, for anyone who's not familiar with a air-to-water heat pump, produces hot or cold water depending on what you want to do for the time of year. It's not like a mini split. This produces hot water or cold water. In the wintertime, the nice thing about it is that I have hydronic air handlers with HVAC, so I can warm the house, and I also have an area's radiant floor heating. So we use the hot water for the air handlers and for the radiant floor. In the summertime, we don't use the radiant floor, of course. We just need air conditioning. So again, my air handlers take that chilled water and it transfers it to the air, and my house gets cool. So with all that, these are 1.25 inch pipes. There are adapters The Apollo comes with a 1-inch NPT fitting, so I had to put an adapter on there, but it's easy. It's just, if you know how to sweat copper, you can do it. Next is electrical. We've got 3 lines here. Bottom line is your 240 AC, which powers the unit, and that goes right to that emergency shut-off switch right on the side of the house. Second is the 240 for the circulator pump. My circulator pump, and I think most out there, are probably 120, so what I had to do with this puppy was put a relay in the house, so when it called for the pump to come on with 240 volts, the relay flips on and flips on my circulator pump, which is in this plumbing and circulates the water from the hot water tank to this unit. The third is low voltage communication lines. You can see they all go over there. And we'll go over that in a second. In the low voltage, there's 3 things. There's Wi-Fi, the Wi-Fi hookup, a console hookup, and a temperature gauge for the hot water tank. And that's all there is to it. That's the hookup for this thing. So let's open this thing up. As you can hear, before I do that, it's running. I turned it on and it's very quiet. And my wife's office is right there, and she works in the offices at night. And the old units, she said, used to sound like a rocket ship. And this unit's very quiet. So let me open this thing up. Now, I did have the cover off. Took the screws out because I intended on showing everybody what it looks like in here. I'm very impressed with the finish of this unit. The last unit I had was actually built pretty terribly. The wiring was not dressed, the wires were too long, they were all hanging in bundles. If you look here, you can see everything's neat, everything's dressed. It's all clean, painted, airtight, dry. When you look down on the bottom here, you can see all the cables are run, they're all dressed, all nice and neat. And now we get into the fun part. Right here I have a communication controller. This hooks up to the main board up here. This is not how I normally keep this, so folks at Apollo don't get upset when you see this. I just ran this. This is a Cat 6 cable I just cut and just did it for demonstration purposes. What I have is the actual communication cable for this runs through this conduit into my house, and I have a jack in my office, so when it's cold or raining out and I need to change the setting or look at the status of my heat pump, I can use this thing in the house. Lastly, the other item I have is Wi-Fi as well. Hard to see here, but I got a Wi-Fi unit, and you can also control the system from Wi-Fi. It's an app that goes on your phone or iPad. So I can either use my iPad to control this, walk around the house, or I can use my console. I like the console better. It's just I like the feel of it better. You can go in here. You can see what's going on with the system. It's pretty cool. It tells you all the numbers, temperatures. You can look at all the settings. So anyway, very happy with my unit so far. We've gotten down in the 30s, and this thing has no problem keeping up so far. Actually, I've noticed that when the heat comes onto the house, the air is hotter, and so it doesn't come on for as long. So I'm thinking this is probably making a little hotter water, which is nice. And that's it. So we'll see how it goes, and we'll go through the winter and hopefully save lots of money. Anyway, thanks guys at Apollo for your help. And as a belated mention, I did have some questions for their tech support. A shout out to Jesus over there, who I've called a number of times with different questions, some of them good, some of them dumb, and he was always happy to help me. So anyway, shout out, thank you to Jesus. All right, guys, have a great day and be well. Bye.
Hello everyone, I would like to show you my installation of the Apollo 3.5 ton air to water heat pump from MB Tech. I had the unit installed for about 3 weeks now. It's the end of January 2024. I bought the unit in November, then it got delivered. I had it sitting outside on the pallet with a piece of roofing over it for a few weeks before I actually got it installed. So let's go outside and take a look at the outside heat pump. Don't mind the mess. I'm still under full construction in the house. I'm living in it since September 2023. But it is still under construction. So first thing, I built a roof attached to the side of the house over it, so snow wouldn't fall on the unit. It's pretty good off the ground. One issue I had was mice got into the shipping crate and chewed up a lot of the insulation around the pipes on the inside here, so I had to go back in and spray foam around these pipes, around the fittings back there. You know, you still see the shreds of insulation, so that's something I had to take care of. So you take the main cover off this guy right here. It's just a few screws there, and then there's another cover here. You take those 4 screws off to get to the electrical components. So I ran my wire in, coming in here, going in here, and then you have 120, 120, and the ground. So the whole unit runs on 240 volts. The only other thing I hooked up was a hot wire from terminal 1 here that goes to the circulator pump inside that circulates the glycol water from the outdoor unit to my buffer tank inside. Other than that, this conduit hole runs the Wi-Fi cable, the controller cable, the temperature sensor for the buffer tank. It all goes through that conduit into the house. And then these are obviously the insulated 1-inch PEX pipe that circulates the water glycol. So it's pretty easy. The unit comes with the 2 fittings, 1 by 1, 1 inch by 1 inch male fittings, and then I just put stainless steel flexible water hose connectors screwed onto here, screwed about here onto the PEX fitting. So PEX line is coming into here, and then this section is just the water hose connector, so I can easily disconnect and connect things if I need to change stuff. So the unit just turned off because it was satisfied temperature wise. my bedroom is right up there. I can't really hear the unit. I mean, it's pretty quiet. So I'm fairly happy with that. Yeah, mounted on the platform, and then there is a threaded connection right in here that I just screwed a poly fitting in and a little bit of leftover PEX to drain the condensate out, because obviously you can see like the fins are icing up. When it goes through the defrost cycle, all that ice is gonna melt and turn into water and drain right out here, and it's just like a river pouring down every defrost cycle. This is just also from the rain right now, but it was just a huge sheet of ice here. So it works pretty well. The drainage, everything is great. Let's go inside and show you the inside. Moving on to the inside. This is my buffer tank, the other big component of my whole system. It's a 500 liter or 130 gallon holding capacity buffer tank that has 2 heat exchanger coils in it, one in the bottom and one in the top. Those 2 are submerged in those 130 gallons of water, and the bottom heat exchanger coil is the dedicated heat pump loop coil that I'm going to explain right now. So my 1-inch PEX lines coming from the heat pump are entering the house right here. Fluid is being pumped this way, first into the Calefi air separator valve that I'm really happy with. Then we have the expansion tank to accommodate the thermal expansion as you heat up the fluid. Then it goes into the circulator pump, and the circulator pump is moving the fluid around and round between the heat pump and the buffer tank. Then we have a pressure gauge to keep the system pressure monitored, and another air separator valve because it's the highest point in my entire system, so air pockets don't collect in any high spots. Then here a pressure relief valve, and then the water heater connectors, stainless steel that just screwed onto these fittings here and here, and it goes into the buffer tank, into the heat exchanger in the bottom of the tank, where the fluid gets circulated, moves through those coils, gives off its heat onto the 130 gallons of water in the tank, comes back out the bottom here, 10 degrees Fahrenheit colder, and then I have a drain valve, and then this 1-inch PEX pipe goes back out to the heat pump, where the whole cycle starts again. Then we have all the communication wires right here. The gray one is for the main controller of the heat pump. We have the temperature sensor wire that's going into the buffer tank, and we have the what's it called, the Wi-Fi transmitter wire, and then in this conduit here is the hot wire that goes and powers the circulator pump. So that's the black wire I showed you earlier that hooks up to terminal 1 in the heat pump itself. So terminal 1 gets that wire and runs it to the excuse me, to the circulator pump. So the heat pump outside is entirely controlling that circulator, and then I just have a white neutral wire that runs back to my breaker panel to complete the circuit so that the pump runs in first place. Now again, the communication wires, I just have them tacked temporarily into place right here. This is the gray controller wire cable that goes into the controller, that you can, like, you know, turn the unit on and off. No, we don't want to do that now, but yeah, you can just, you can see what it's doing. Monitor everything, inlet temperature, outlet temperature. Then this wire is the Wi-Fi wire, so you just you know, the whole unit gets delivered with all of this stuff. You wire up the power supply right there, and then this is the actual Wi-Fi transmitter that links up with your home internet. So you then download the app onto your phone and set it all up, and that way you can be out of the house 1,000 miles away, and you go onto your phone in your app and you can see what the heat pump's doing. You can turn it on, turn it off. You can change the temperatures. It's really handy if you're away for like a couple days, you know, and you want a warm house when you come back. So I can turn on the heat pump or change the set temperature so that it's cozy and warm by the time I get home, because I have radiant floor heat. It takes, you know, 6 to 8 to 10 hours to heat those floors back up once they're cold. So the question still remains, why did I get this huge buffer tank? Seems overkill, but I'll explain that. So again, the bottom heat exchanger coil is the dedicated heat pump loop, part of the heat pump loop. That whole loop holds about 8 gallons of fluid, out of which 4 gallons is propylene glycol. So I bought for $120 a 5-gallon bucket of propylene glycol. Now, if my entire system, everything in the buffer tank and everything going into my radiant floor, and then later on to my hydronic radiator panels in each bedroom, which these lines are for that are not hooked up yet in my manifold, if everything was running on glycol, I'd be spending a fortune on glycol every 5 years, because about every 5 years you're supposed to replace the glycol because it breaks down. So I'm saving a lot of money by just running the parts of the system on glycol and water that are actually in danger of freezing, which is only all the outside parts, the heat pump and the lines that go out to the heat pump. So that has to be freeze protected. Obviously, if there's a power outage and no water is being circulated through the heat pump unit outside, water would just be sitting there. The pipes would freeze and burst and break all kinds of stuff. So that has to be freeze protected. Everything inside the house which is my second closed loop, that I don't care. That can be purely water. I mean, the house will never seen below freezing temperatures. If it, you know, like I would have to have a power outage for weeks and weeks, and at that point I have my backup heater. I'm saving costs on glycol. Secondly, this tank is basically a huge thermal battery. 130 gallons of hot water sitting in here. That's a lot of BTUs stored inside this tank. So what I am able to do is I can shut off the heat pump in the evening when the temperature drops in the winter. I'll shut off the heat pump loop, so the circulator pump will stop running, the heat pump will stop running. I can either do it right here from the controller, unit off. Nope, not right now, but yeah, I can shut the unit off, and then I can keep this circulator going and slowly run that hot water, keep it running through my radiant floor, which the floors itself act as another thermal battery, because it's, you know, like about, I don't know, 7 tons of concrete or something. So that way I only run the heat pump during the day when the temperatures are warmer, which means I get a much higher COP, coefficient of performance. So the heat pump is running more efficiently, I'm using less electricity, and I still keep the house pretty much at the same temperature within like 3 or 4 degrees. And then in the morning, when I wake up, I turn the heat pump back on, and that tank heats back up and keeps circulating water round and round. It also is a little bit of a safety buffer in case of a power outage. So if there was a power outage, and I can't run the heat pump at all, I still have that water saved in here. So I can stretch out, I can bridge that power outage with just that water inside the tank, and don't have to run my backup heater if it's only a power outage for like 10 hours, which is most of the time. Yep. So as mentioned before, inside the tank, apart from the heat exchangers, is just water, 130 gallons. That water is being sent through this line, coming through the circulator pump here, another expansion tank for that closed loop, and being distributed into the manifold and then into all the load sides, like the slab, and then later on the hydronic radiator panels that are being hooked up to the remaining connection ports of the manifold. The second heat exchanger coil in the top, I'll explain that real quick. That is part of my domestic hot water preheat system, basically. So my cold water is coming into the house, behind here, going down, coming through the floor. It's coming in here, going first through a cold water manifold, then keeps going behind the wall, coming back out here, and entering the buffer tank here, entering the top heat exchanger coil. So it comes in cold here, runs through the coil, gets heated up by the 130 gallons of water, which in turn are being heated through the heat pump loop, through the heat pump itself. So the water gets preheated, comes back out warm, and going in to the cold water supply line of my domestic water heater, which itself has a heat pump unit on top of it. So if I'm ever, if I draw hot water at the sink, shower, whatever, the makeup water isn't even cold. It's already preheated, which means that this heat pump of my domestic water heater is basically not really running ever, or very rarely, just to bring it up to temperature all the way. Excuse me. So the benefit of that is I don't have this heat pump working against the outside heat pump. So the outside heat pump is heating my house, is heating the floor, heating everything up, and then this heat pump would suck the heat back out of the house, transfer it onto the water, so that I can then shower with it or do whatever. So this heat pump would be competing with the other heat pump, which doesn't really make sense. That way that I have it set up right now, I have the outside heat pump through the coil, heat those 500 liters, which then heat the house and also heat the cold water supply of my domestic hot water. And the system runs great. I have no complaints. I love it. Everything works out the way I hoped and thought it out. To give you an idea about my efficiency so far, the heat pump uses around between 40 and 60 kilowatt hours of electricity a day, which translates to, here in Vermont where I live, to about $6 to $8, I think, or something like that, a day to heat my house, heat my domestic hot water, doing everything. I'm pretty happy with that. I don't know if it could be better. I know it could be a lot worse. I have a 1,500 square foot house, huge windows. I still have a lot of heat loss. But I'm not even done building yet, so these windows will actually all get doubled up with another set of double pane windows to make, in the end, quadruple pane windows out of them, because I got these windows for free. I already did this experiment with these little ones up there. So the big windows still have a horrible R value. I'm losing a lot of heat in 1,500 square foot house, but yet it already performs great. Toasty, warm, nice floors. I honestly couldn't be happier, and I think I did the absolute best decision with buying the Apollo 3.5 ton heat pump and building this system in conjunction with everything else that I explained to you. Yeah, I'm extremely happy. It's frigidly winter outside right now, and it's very comfortable inside. I mean, you see me walking around in socks, and I'm wearing t-shirt. So thanks. So how has the heat pump been performing in terms of energy usage? I had the unit running for pretty much exactly 3 months now. I installed it January 3rd, and then now it's April the 2nd. I have an electric meter hooked up to one of the hot legs of the heat pump that reads 922 kilowatt hours. So there's 2 legs, hot legs going out to the heat pump, which means it has to be doubled up, give or take 1900 kilowatt hours of usage, which translates here in Vermont to around, for me, to around $270, $280. That is for heating the house and my domestic hot water. So I'm very happy with that. I didn't even expect it to be that well. And then bear in mind also that the house isn't even finished yet. I have these huge windows everywhere that are not even done yet. They're all double panes, but they will get another double pane in front of them to make it more insulative. So I still lose a lot of heat through all that glass, and yet still I've used very little energy to keep the house warm. So it's very efficient. I'm very happy with it. This energy monitoring has been over the coldest months of the winter, January, February, March. The last snow literally just melted away yesterday. We're gonna get some more in a week, but yeah, I'm very happy.
Hi, my name is Jason. I live in northern Michigan, and I'm here today to talk to you a little bit about Apollo heat pump. We just built a barn dominium. You can see here in the background. We don't have it 100% complete yet, but we live on a street that doesn't have natural gas. So we're either gonna have to go with propane or a different type of heat source. So we decided to go all electric, and we chose an Apollo heat pump as our choice. Okay, so I'm back. I wanted to show you the apps real quick on my phone, how I can control the heat pump from any location, and I can also control all the fan coils. So on my phone, I'm going to show you the apps. So right now we have 2 apps on here. Well, first we're going to go to the fan coils, and we'll show you all the different fan coils and actually the in-floor heat. So right now I have 5 things on cooling mode. Each one of them I can control, and I have the 3 that are in the in-floor heat. So those ones are currently in off stage. So if I wanted to click on one of these, I could increase or decrease my heat or cool, and they would automatically update through Wi-Fi. So the other is the actual heat pump. So if I wanted to access the heat pump, I could open it up, and then it currently tells me what my in and out temperature are. So since it's in cool mode, the temperatures are low. So I could go to settings, and I can control anything I wanted to do from our settings, all the way up and down, from turning the pump on automatic, turning the pump on all the time, so on, depending on your cooling or heating needs. Okay, just to go over the heat pump one more time here. So we're looking at the heat pump on the back of the house. I just wanted to say a couple of things about the pros and cons. So the pros are, I think it was relatively easy to install. We did have to call tech support a few times, but mostly I talked with Jesus in tech support, and he did a pretty good job walking me through anything I needed to do. Other than that, I'm pretty happy with our electric bills, so pretty low, pretty happy with that. Also, A couple of the cons, I think. The only thing I would have done differently maybe is probably placement of the outdoor unit. I probably would have placed it somewhere away from the patio. Not that it's loud or real loud, but it does come on when we're out here sometimes. But also it's, you know, kind of right in Grand Central Station, and probably be better if it was located somewhere where we're looking at it all the time. But overall, I think it's pretty efficient. So it's a good choice if somebody doesn't have natural gas and they're looking to do something that's pretty efficient and able to heat their house and cool their house and do their domestic hot water at the same time. Here's our mechanical room, and this is the setup we have. So we have the 2 lines coming in from outside. They ran down through the floor from the outside and down, and then up into the pump station. So the pump station has the control board on the front. You can access to control heating, cooling, domestic hot water, and then we have all the lines going from all the different things in the room, from the fan coil manifold down through the floor into the other manifolds for our in-floor heating. So we are on a slab, so our slab is heated with hot water. So, and then the line that goes from the hot water into our hot water tank. So it heats a coil in there, and then that warms up the hot water and then comes back out. So we have a differential bypass valve on here, and then we also have a pressure gauge. So that's the basic setup for it. We also have a relief valve located down on the bottom here, and that goes over into the tank, extra drain, and down into the floor. Here's the heat pump on the back of the house. So we have the 5-ton heat pump. You see we have 2 lines running in. We have the electrical hookups. We also have the signal wires that go from the inside to the outside, going through a box, through some conduit in the wall. We chose to put our utility room up in the upstairs of the building. And so the lines run in the house, up through the floor, and then into the utility room. So you can see it's not running right now, but this is our heat pump on the outside of the house. I'm going to take you inside and we will show you the rest. So we've been through 1 winter right now so far of the heat pump, and basically compared to our old house, the electrical bills are pretty much the same, no difference. Even though we had natural gas at our other place, we currently just have this heat pump here at our new location. So our electrical bills were running around $300 at our old location, and currently in the middle of winter, our electrical bills were around $300 when it was the coldest, and now currently our electrical bills around $150 because we're not heating too much because it is getting close to summertime. So we have the unit in cool mode now, and of course it's not running right now because our inside of our house is probably around 68, 69 degrees. Here's an example of one of the fan coils. So currently right now the fan coil is off. So if we were to go to the thermostat and control the thermostat, we could turn it up or down. Right now it's pretty cold in here right now, but we could turn it down to say 65, and it would actuate the fan coil, and it would start blowing air over the coils, and then eventually the heat pump would go into cooling mode and it would start cooling the water, and then we would have cold air or air conditioning in our house. So we're going to go back to that and turn that back up, and then coil will go back off. So we have 5 fan coils. We have a fan coil in each one of our rooms. We have about 2,200 square feet, and we have a fan coil in the master bedroom. Each bedroom, we have one in the loft, which is the one we're looking at right now. We have one in the great room, which is located down there. And then we have one downstairs in the master bedroom. So that is the basic setup for ours. We also have a pellet stove, which we use for backup heating, just in case. So that's located down there. It's also nice to have, just so we can have a fire going if we wanted to, and it supplements the utility.
Good morning. This is Richard from Littleton, Colorado. I purchased a 6-ton air-to-water heat pump about 3 months ago and installed it and have been using it for this winter. I do plan to use it for cooling. Haven't had a chance to see how it's going to run for my cooling system, but for now the heating system, it is doing a great job. It works with a solar hot water system and gas boiler system that I have installed in my 7,000 square foot home that I built back in 1996. The unit has, on the right side of the view from where we're looking, 1.25 threaded ports to run piping in. I ran 1-inch water PEX piping from the house system into the heat pump and back. It does come with 1.25 to 1 inch couplings so that you can, connect your, smaller piping if you decide to do that. You can hear the heat pump running right now. I believe it's running in low speed at low load. It runs in parallel with my solar hot water system. So the solar generates heat during the daytime when the sun's out, and that water runs through the heat pump. The heat pump will cycle off as the solar catches up to the heat load of the house. And then as the temperature of the water starts to cool below set point, the heat pump comes back on and heats the house. The heat pump does a great job producing the hot water I need. I have radiant hot water heat and fan coils that heat and cool the house. You can hear the heat pump now ramping up a little bit from the low load condition startup, but it is very, very quiet. I'm going to move in closer so that we can see the side view of the unit. The 1-inch piping comes from the house through the unit and back through the house. The extra pipe that shows on the picture on the top of the pipe there is an actual covering of the vent. I got an air vent on the piping to get the air out of line. I will move in closer to the heat pump nameplate so you can see that. Also, there's a gauge, high pressure gauge on the side of the unit that comes with the unit. That's the back view of the unit. Side view of the unit. There is a condensate drain when it goes into defrost for winter operation. You can kind of see the hole that it drains from in the back corner. Again, you can hear the unit running and it's very quiet. This is a view of the digital display that comes with the heat pump unit. Comes with the cabling for a temperature sensor for an indoor tank, which I don't have the tank. I have a large enough system that it acts as a tank for me. The digital display is mounted on an adjustable arm, a cell phone arm for that matter, but you can see that it does give you all the information. From this digital display, you can make all the adjustments that you need to for the heat pump. The unit also comes with a Wi-Fi component that allows you to use their software to make any adjustments that you may need for operation. Also, you can see all the operating parameters on that software app that they provide with the unit. Hopefully this gives you an idea of the unit and its operation, and look forward to using the unit for summer cooling this summer.
Hello, I'd like to do a little walkthrough of my heat pump configuration. This is a 5-ton condenser unit, which I bolted down on top of concrete blocks, and I had a plumber come out and run 1¼ inch copper type M copper pipes, one for flowing in and one for flowing out, and it goes right into my basement. And it's actually very straightforward. You know, any plumber can do this. And then I had an electrician run some tight flex. There's 3 sets. One is a disconnect. One is a communication wire, and I believe the other is another set of communication wires that go into the heat pump station. And so it's actually very straightforward. There's only those 3 connections, and with the right type of boxes and you know, connections ahead of time, this could be installed within less than an hour if you know you have the right electrician. It didn't take very long. Okay, just a matter of getting the right equipment, which is a disconnect and some external boxes and tight flex, standard stuff that you'd get from an electrical supply store. Yeah. And then next I'm going to show the heat pump station.
Tips to prevent frozen pipes this winter. Keep the heat flowing. Insulate, insulate, and insulate. Seal leaks. Let faucets drip. Disconnect and drain.
Protect your home with these simple yet effective strategies. Follow us for more tips.
A new age of heating come to us.
Explore the power of our Apollo heat pump. Uncover the benefits of choosing our high-performance heating solutions. Experience the difference with our Apollo, where efficiency, versatility, innovation, reliability, and budget-friendly technology